Okay, number 7. Number 7, we're now looking at mirrors, lenses, and how light is bouncing around. So we're going to start looking at 7A first. For 7A, this is a flat mirror. Take note what you're looking at. I've had a lot of people confused. They see the fact that it gives them a P of 5 centimeters, an F of 2 centimeters, and a height of the object of, in this case, 2 centimeters. And you get so stuck on doing concave or convex, diverging or converging, that you just do the one you know and you're not doing the one you're being asked for. So pay attention to that. So in this case, we have a flat mirror. So we have to draw our system. So we take a ruler, and essentially we draw our horizontal line, and then we draw our mirror. Now our mirror is always considered the vertical line, no matter what. In this case, it's pretty simple. It's the flat mirror. From here, I now need to measure out where things are. Okay? Graph paper is really easy for this. You could do it in scale of the graph paper, or you can do it in the scale of the ruler that you have. Okay, and so, in this case, we're going to do it by ruler because my light board's not graphed out. So I'm going to measure over. In fact, I'm going to scale it up a little bit so you guys can see this. 1, 2, 3, 4. So this is P. And then 2 centimeters away, this is where I have F. And then it's 2 centimeters up. So right here. So here's my object. Here's my mirror. There's my focus. Now, flat mirrors are pretty easy. Okay? And a flat mirror, the first line goes in straight at the mirror. And guess what? It bounces straight back. So when it does that, that's great, but it's not really helping us. The focus, this actually doesn't exist for flat mirrors. It's a trick part of the question. Sorry, but that's what happens. Now, another one you could do is you could take for flat mirrors, you could hit here. This will give you an angle of incident. This theta here, well, this and this angle will be the same, or that angle and this angle are the same. So if I have the same length, see, you don't know where to put it. So I could use a protractor to measure this. Or I know the fact that the light bounced, so it came in and bounced, but there's an imaginary line right there. And that imaginary line is going to have the same distance, in this case here. This is Q. In the mirror, this distance here is going to be the same, and so Q is going to equal 5 centimeters. I've asked you to tell me this. Is it real or is it inverted? Is it, excuse me, real or virtual? Is it inverted? Or is it erect? I want to know what Q is, and I want to know the height of the image. Okay? So, for our mirror problem, number 1, this is where my image shows up. Okay, there's no 3 lines for our mirrors. It comes in, it bounces back at the same angle, and so in this case, it has a dotted line because the light does not go into the mirror, it reflects. And so this will give me a virtual image. This object, it's still facing up, that point goes up, so it is erect. The angle in and angle out are the same, so the distance you perceive is the same, so it is 5 centimeters. And the height of the object, I could do this by measurement, which, hey, that one's 2, oh look, that one's 2 centimeters. Or I can do it by calculation. Here's one, they're going to be the same, so I wouldn't really worry about it. And that's how you do the mirrors. And next we'll look at the aspect of curving a mirror, be either concave or convex, which is B and C. And then we'll do lenses, and you're done.